Hello, and welcome to the virtual open house for the 2020-2021 school year. There we go. Oops. My name is Andrew Beck. This is my third year of teaching at ETHS, my third year teaching overall, and also my third year of teaching AP Physics 1. I'm really excited that I'd get to teach AP Physics 1 again. I really enjoy this course. I think it's a really interesting course where we really get to build up lab ideas. So the content of physics and the idea of doing science are held kind of in equal regards in this class. And I think that's really neat. I think it's a really cool blend. A little bit of my educational background. I have a bachelor's degree from the University of Illinois, Urbana-Champaign in physics and a minor in secondary education. And right now I'm working on my master's degree from Montana State University in science education. So I'm really enjoying teaching, and I've been really enjoying teaching your students this year, even though the format is a little bit weird. It's been great getting to know them and learning with them so far. If you need to reach out to me at all, my email address is becka@eths.k12.il.us, or if you want to give me a call at 847-424-7674. That's my office phone, and it should redirect through my cell phone. Nobody's tried to call me yet, so if it doesn't work, just kind of shoot me an email and be like, hey, I was trying to call you, but it doesn't work, and I will figure that out. But right now, I don't know if it works or not. So a little bit about what physics is. Physics is just using data and observations to discover rules and laws about the world around us. So we can make observations and notice what's going on around us and say, hey, what kind of rules are all of these objects following? I see this happening over there. I see it happening here. And what's staying the same? What's going differently? And then using those ideas and those models that we build up to then predict future behavior. So physics is really cool. I think it's a really interesting class because it's everywhere. It's all around us. And it's really applicable to everything that's going around us, which is really neat. So you can see physics everywhere you look, which is really exciting. So a little bit about AP Physics 1. It is an algebra-based introductory college-level physics course. So by the end of it, your student could earn credit for a introductory college-level physics course, which is really cool. So they wouldn't have to take that in college. So really the main idea of AP Physics 1 is you're cultivating this understanding through doing investigations and labs. And in doing so, we're going to learn about things like Newtonian mechanics, work, energy, power, waves, sound, and circuits. A lot of this course is done through labs traditionally, and we're trying to find a good way of bringing that lab experience to your students through this virtual learning. So a lot of this is taking the shape of either doing kind of like standing up, like walking around your space labs, or doing stuff outside where you're kind of taking this informal data, or you're taking video data and analyzing it, or we're doing these simulations online where we can really go in there and analyze data more closely. Or we're doing these open-ended questions where it's a little bit more fun and a little bit more like, hey, try to answer this question. Maybe there's no right or wrong answer, but what evidence can you bring to the table from what you're seeing to answer a question one way or the other? So a lot of it takes a lot of curiosity, a lot of creativity, problem solving, and it's really interesting because it's a different way of thinking. So it's not so much just like, hey, here's this number, here's this number, here's this number, let's plug it into an equation. A lot of it is, okay, how can I actually find that number? What could I do in a real world setup where I could find this quantity or find this variable? What could I actually do? So it's kind of cool in that it's not just all about plugging stuff into an equation. It's about actually thinking about how we can perform physics, which is really great. A lot of what we're doing is through discussion-based learning. So we're in groups, we're talking to each other. So making Zoom breakout groups where we're able to kind of have these smaller scale discussions while we're working on solving problems. Again, like I said, a lot of it is very lab-centric. So trying to find ways to bring labs into this virtual learning. It's difficult with AP Physics 1 because a lot of the measurements, they need specific tools that we just can't give to students, like motion sensors or all these kind of like fancy equipment that's like Pasco equipment from this company. So it's kind of difficult, but we're finding ways to make it interactive and still make it lab focused. We've been using this website called Pivot Interactives where students can upload their own videos or view different videos and actually take data from those videos. And collecting data from what's just around us. We can use our phones as stopwatches to collect time data or rulers to measure things. So we're still able to do some labs and trying to find the right balance in doing that. Like I said, it's a challenging class, but I hope that it is fun. I have a lot of fun teaching it, but I hope it is fun to think about the world in that way and think about taking measurements from what's around us. So, like I said, a lot of what we want to get out of it, it's not just the content of physics, but it's the practice and the actual doing of science. So it's not just saying, okay, well, here's this physics content, but it's saying, hey, how do we actually do science? How can we perform science in our day-to-day lives? So we're going to do that through modeling. So kind of seeing something and saying, how can we represent that? Can we represent it with an equation, represent it with a graph, with a drawing, with an image? Doing mathematical routines, so actually using math, asking scientific questions. So instead of just like broad, whatever kind of like, oh, I wonder this question, actually bringing it down to saying, oh, if this changes, how does this change? Actually constructing these scientific questions, experimental methods, so performing experiments and actually identifying, okay, what can I change? What can't I change? And what do I need to keep as controls if I want to run an experiment? Then finding data and analyzing it, creating arguments and saying, okay, this is what I found, this is what my data is telling me, and this is what I can conclude from my data, and then connecting between the different topics. Everything's going to play into each other. We're going to see all of these units kind of connect. So finding ways to connect these ideas and use them in together. Kind of what the day-to-days look like. So we start our days in breakout groups in Zoom, just kind of talking to each other and saying hi and having kind of these smaller scale discussions. Like in class, when you sit down, you sit at your table and you talk to your classmates. So trying to find a way to replicate that just to make it feel a little bit more personal in the class and not just, faces on a screen. So trying to find a good balance of doing that to start out the day. Then we'll have some sort of question, some sort of either we'll review content from an earlier day or we'll see some sort of new situation and try to apply everything to this new situation. Then we'll make some sort of observation and say, okay, well, what we want to answer this question. How can we do that? If we were going to do a lab, what data would we need to answer this question? How can we identify variables from this idea and break that and turn that into a lab? And then we'll do that. We'll create a procedure. We'll take and test data, whether that be in real life, through simulations, through online interactives that I was talking about. Then we'll analyze these data. We'll find trends. And then we'll kind of talk about in a full group what we noticed. What did our graphs look like? What equations did we get? What did we conclude? Was this realistic? Was it not realistic? And then we'll usually formalize what we're doing in the form of notes. And then we'll have an opportunity to practice that. And then we'll kind of put our learning to the test with skills checks, which is pretty much just quizzes. And I'll talk about that a little bit more. So the topics, the units that we're going to cover in AP Physics 1, the first semester we have kinematics, so how things move, kind of describing the motion of objects in 1 dimensions and 2 dimensions. Then we have dynamics, so thinking about forces and how we can actually get objects moving. Then we have circular motion and gravitation. Then we'll look at energy. Then the second semester we have momentum, simple harmonic motion, electrostatics. We do some circuits, and then some waves and sounds. And then at the end of this course, we're going to still take an AP exam. So if you're familiar with AP exams, or if you're not, at the end of the year, students in an AP class are able to take an AP exam for the chance to earn college credit. So they won't need to take a college course their first year in college. So it'll kind of give them credit for that, which is really cool. The AP Physics 1 exam is scheduled for Wednesday, May 5th. Right now, the College Board has said that exams are going on as usual. So one thing that's kind of interesting, if your student was in an AP class last year, what the College Board did was they cut some content and they said, okay, well, we recognize that you're online learning. We're going to cut some content. This year, they're not cutting anything, so it has the same amount of content as a usual year. So this pacing of the class may be a little bit quick, a little bit faster than it usually would be, just to make sure that we can cover everything for that AP exam. And then on the AP exam, there's going to be multiple choice questions and free response questions. And all of the exams that we take in this class are going to mimic that format, so students get used to doing multiple choice and free response questions on an AP level. And then kind of wrapping it up with the grading/homework policy. So classwork is going to be 20%. So just kind of what you're doing in class. Are you turning it in? Are you putting an effort forth? And are you getting enough to kind of have this discussion from what you're doing in class? Labs, are you performing the labs? Are you having good creative ideas? That's going to be 25%. Skills checks, those are going to be quizzes. And we'll take those more often. That's going to be 25% of the grade. One thing about the skills check to kind of keep note of is that those are retakeable. So whenever students take a skills check, they're able to retake it for more points. So if I see that a student didn't do too well on a skills check, I've been sending them an email and being like, hey, just a reminder, you can retake this during AM support or during office hours on Wednesdays and Fridays and Mondays. But if you kind of notice, like, oh, my student's grade just kind of dropped. Okay, I see a skills check grade just went in. Maybe just give them a little reminder saying, hey, just a reminder, you can retake that. Did you email Mr. Beck to set up a time to do that? And then the unit assessments are going to be at the end of the unit. These are going to be 30%, and they're going to look like AP tests. So they're going to be free response and multiple choice, and they're going to mimic this AP style. So they're usually tricky, but students will, again, have opportunities to make up points through doing corrections. So that's kind of all that I have. If anybody has any questions, again, I'll put that information up there. Feel free to reach out, send me an email, or give me a call. And yeah, I hope you have a good rest of the day. And again, if you have any questions, feel free to reach out.